All right, this is MCT4C, day in around day 10, and this is the first lesson of Unit 2, and this is a review lesson, stuff that you did last year in grade 11, and it doesn't really appear in our textbook, but it's important stuff to remember, stuff that some students have trouble with, so we're going to spend a day doing a little bit of review of what it means to be a function. We see the 3-minute review goal is to review the concept of function and related skills. And specifically today, in the 3-minute review is the notation. This is function notation. And it's not that difficult. Essentially what it means is when you have a function that the x is the input, right? No matter what the rest of the equation, the rest of the rule is, wherever there's an x, and x becomes something else like 4, well, it becomes 4 elsewhere in the function. So f at 4 then is, I just took out the x and filled it with what x became in the notation, and this is just some arithmetic now. So 4 squared, 16, plus 12, that was 28. No problem. So for b, f at whatever, still the same function. So all the operations that happen next to the x happen to whatever I fill in. So when I take out the x, there's a little hole that I leave with brackets there, and then it's equal to whatever. And b, it's -3, and that's no problem. Hopefully do that in your head. -3 squared is +9. +3, -3, subtract 9 is 0. And that's got a special significance for this type of function, but we're not worried about that now. It could be that what we fill in for x, what becomes the input, is another expression, in this case x plus 1. Then instead of arithmetic, we've got a little algebra to do, right? X plus 1 all squared, be careful there. Some people call this FOIL. Multiply that out. I'm going to multiply this out. Multiply 3 times everything in the brackets, 3x plus 3. And then some people can sort of do this in one step in their head, but I'm going to multiply everything by everything. Some people call it FOIL, and that's fine. I'm just multiplying everything in the first bracket by everything in the second bracket. X times x is x squared. 1 times x and x times 1. X and x, and 1 times 1 is 1. Copy down the rest. Find the like terms here. There's some like terms there, there, and there. 1, 2, 5x. 1 and 3 is 4, and then that's the answer. And that's it for function notation, right? Essentially substituting. On to the lesson. Function review 2.0, and the 0.0 means it's not a section in the textbook, but still something that we're going to be responsible for. So what is a function? A function is a math thing. A function is an equation. A function is a graph. We think of all these things, but there's a real sort of technical math definition, and we want to be, this is the rest-all definition. If you look it up in a textbook somewhere, you might get slightly different language, but this is what rest-all says a function is. A function is a rule. That's it, just a rule that maps. By maps, we could use the word takes, but maps kind of has a math feeling to it. Maps elements, and by elements we mean numbers usually, of one set. And we'll talk about what these sets are. This first set, the input set, is the domain, right? And I can almost hear you groan out there in cyberland, domain and range and all that stuff, and I know how some students don't like that, but it takes a function is a rule that maps elements of one set in the domain to exactly exactly one element of a second set. And that second set we think of as the outputs, or the, you know, the math word for it is the range, domain and range questions. So it's going to be one of the things we're up to today. And think of this, I don't know if you've ever seen these sort of bubble diagrams. There's kind of a picture where we think of this as the input set. This is a set of numbers, it's the input set, this is the domain. So for instance, one of the numbers that might be in there is number 4, the number 4. And here's the second set, it's the range. The idea here is that the rule maps this to exactly one element of this set. There's not two branches going off, it's only one. And this is the rule f that sort of changes 4 into 28. This is a function. We also saw from the 3-minute review, -3 became 0. And we saw in general, x was a member of the domain, and it got mapped, or it got, the output was, well, it was an expression, wasn't it? It was x squared plus 3x, whatever x happens to be. And we think of these sets, the domain is, think of those as the input set, where the range is the output set. I'll talk in terms of inputs and outputs quite a bit. These are the x's and these are the y's, or we also call them the f at x's. This was f at x. We also think as the inputs as the independent variable. Independent variable, and then this one's dependent. You know, what do we get for an output? Well, that depends on what the input was. You know, what's the output? Well, it depends. That's dependent variable. We also see some other pictures here that in a table, when we get into application, sometimes it's not clear what the input variable and the output is. But anytime that we have a table of values, the first thing in the table is the independent value. That's the domain. The inputs are the first thing. Same thing in a table like this. This is the domain. On a graph, we know that we always put the inputs, I should be using a ruler here, but oh well. The inputs along the horizontal axis. So this is the horizontal axis over here, and the outputs go on the y-axis, the vertical axis, and that's the range. That's the inputs along the ground and outputs up and down, right? Hopefully that's all review and you remember that. Keep that straight. Okay, so given a sketch, we can tell if a given graph is a function by the vertical line test. So a rule, whether it's written in table form or graph form or these bubble diagram forms, we can decide whether it's a function or not. We said that if we had any time a second value peel off of one input gave us 2 outputs, it says one input gives exactly 1 output. And that's the idea of the vertical line test. If I had a graph of a function, so that here's a function, and this time I am going to use a ruler and be fairly neat. Maybe I had a line. Right? Make this a line, just a line. I'm going to put arrows on both sides. Oops. Yeah, I know you can do this a lot faster. No, that's why. So we think about for any input, is there exactly 1 output? Yeah, and if I were to do that, any input, is there exactly 1 output? I can think of another, vertical line. This is going to be my vertical line test. Maybe I'll make it a different color just so it'll stand out. I'll make it red. And so when this vertical line goes across here for any input, and that's what we're thinking about, the x is an input, does it cross the graph in only one spot? And if it does, that means there's only one output. one input, one output, vertical line test. So obviously that's a function. And most of the graphs that we've been dealing with all in high school are, like this was grade 9, right? Lines were in grade 9, and they were obviously functions. We didn't call them that then. You just learned the language function last year in grade 11, I think. But most of the graphs, parabolas, exponential functions that we talked about last year, all of those were functions. So even if we had a weird graph that might, I call this a squiggle graph, right? This squiggle graph, is it a function? Well, we don't even know what its equation was. We can't, table of values and all that business. But what I can do is grab a vertical line and see, does it cross the graph always in one spot? And if it does, and how I do this in your notes, because obviously you can't record this into your notes, is just, grab and just show that the vertical line only hits it in one spot. Of course, in contrast to this would be non-functions. If everything we're used to in high school is a function, lines and parabolas and exponential function, what would a non-function look like? Well, hopefully you could think of it, right? One of the ones that students come up with pretty quickly would be, we know in grade 10 we talked about the parabola like this. Well, what happens if the parabola was sideways? I'm going to change this to black, by the way, just so it matches my other ones. Well, now I can see that my vertical line, I'm going to grab it over here, sometimes it cuts it in only one spot, but for a lot of values it cuts it in two spots. One input, that might be x is 1, and I get two outputs here and here. So this is not a function. And I'm going to show this on my note by having two circles. One input, two outputs. Not a function, not a function. And you can probably think of some other ones. Another classic one, that shape that you're used to, is the good old circle. Right? And I can see that my vertical line cuts it in one spot here and one spot here, 0 spots over here, which is okay. It's for an input. Does it have 2 or more outputs? In this one, we see it does. Right there and right there. So you can get those examples into your notes. Oops. Get my vertical line, put my vertical line aside, and we'll pick it up in part 2 in just a second, okay?